Welcome guys. I think we should stop using Friendly for now and focus on Circuit Wizard and the PDF we're using. Before we move on, I would like to show you how to use ammeter to measure current. So we use ammeter in series with the circuit, not like by voltmeter that we use in parallel. So if you want to use ammeter, you put a probe. You use this the ammeter to make the circuit like this. So run this to this, yeah, and you break this. You break this. So let's play it. Now the ampere is 0 ampere. So if you play it now, see it's 7.02 milliampere. 7.02 milliampere. So if we increase this this value to 10 kilo ohm, so the value of the current that's flowing through the circuit should reduce. It's now 8.09.75 microampere. So that's the reason why in the PDF they said phi equals to I times R. Phi equals to I R. This is Ohm law. So phi is directly proportional to I. So and inverse upon phi is directly proportional to I and V and R. So I is directly proportional to V and inverse proportional to R. That means if you want that means I is inverse proportional to R. That means the higher the current, the lower the resistance. If you want a high current, you need to lower your resistance. But if you want a high current, you need to increase your voltage. So it's either you increase your voltage or you lower resistance. So that's how you can get a higher current. Are you getting it? So let's move back to the circuit. So now we have 8.09 microampere. So let's now if you want to have if you need a higher current, is either we reduce the resistance or we increase the voltage. So let's increase the voltage to 24. So the ampere should increase also. It's now 2.28 milliampere. From micro to milli, you see the difference. So to increase it further, we can reduce this resistance to like 470 ohm. 470 ohm. So now let's play it again. It's now 36.42 milliampere. The higher the ampere, the higher the current, the brighter the LED. So but when the current gets to certain point, the LED will explode, as I showed you on the other time. So now let's move to something else. I want to explain the connections of resistor, series parallel connections. So you can connect resistor in 2 or 3 ways. Is that you connect it in series, or you connect it in parallel, or you connect it in series and parallel. So series, this is series connection, and this is the parallel connection. If you connect it in series, the total resistance will increase. You just add it together, R1 and R2. That's the series connection, R1 and R2. Let me show you in the circuit. So let's for another circuit, okay, another resistor, okay, connect this to this and this, escape, and this and this. Okay, before we connect this, let's check the ampere. Okay, the current is now 36.42 milliampere. So now let's connect this resistor to it. Okay, where is it? Okay, let me stop it first. Sorry. Okay, yeah. So delete this delete. Now you know the resistance has increased by 1k. That means this current must reduce, since current is inversely proportional to resistance. So let's play it. You see, so the current is now 14.16. so it has reduced from the former amount to the new to a lower one, to a lower value. So that means when we connect resistor in series, the resistance increases and the current reduces. So let's go to the second connection, which is parallel connection. When you connect resistor in parallel, so this is the total resistance that you have. The total resistance will be R1 times R2 divided by R1 plus R2. So that means if you have 1k, meaning of k is 1000. If you have 1k here and 1k here, and one times 1 will be 1, right? And 1 plus 1 will be 2. That means the total resistance that you have will be what? It will be 0.5k. That is 500 ohm. Okay, let me show you the calculation. This is the formula. So R1 times times RB, I mean RA times RB. I represent it by RB instead of R1, R2. So divided by RA plus RB. So my RA is 1000, my RB is also 1000. So when I run this code now, I printed this result out. It's now 500. Now let me change this value, change the value of R1 to 500 ohm. So the output that we have now is 333.33. That means it has reduced from 500 to 333. So let's reduce it further. So now it's now 47, and we have the first resistance is 1000, and second is 50. So that means the value of the total resistance is dependent on the least value in the network, the least value of the resistance in the network. So you know, since we have a very small value of resistance, that means the total resistance will also be small. So but if you have like 5000 now, 5000, so 5500, okay, let's say the total value. The value is now 846. So it's now a function of this smaller one. So that means if you're in a parallel connection, the resistance reduces, it doesn't increases. So it's going to increase, it reduces. So that means okay, let's show that in circuits. So let's connect this in parallel. Okay, let's delete this. Okay, take this here. Okay, yeah, okay, sorry, okay, yeah. Now before we have something like I think 14 point something milliampere. So since the total value of this resistance will increase, we have 470 and 1k now. Instead of only we have 470 before, now we have 470 plus 1k. So let's put 470 and 1k. So you can use a calculator to do this. So there's nothing special in it. You can use a calculator to do this. So okay, we have 319. So the current that will flow now will change. Okay, let me play it. We have 47.69 milliampere. 49.69 milliampere. So let me remove this connection. So that okay, it will be as if it's only 470 that is working now. Now that I've removed this connection, So let's say the circuit, 36 point something. So it's now 40, it's now 470. And before, when we used it in parallel, we have what? We have 30 something, I think. Okay, let me check back. Okay, yeah, play. So we have 47.69. So that means the resistance has reduces. So and the resistance has reduces. So that means the current will increase. So that's all for parallel connection and series connection. So, and if you want to use series plus parallel, just put another series here. Another series here. So connect this to this. Okay. This to this. Okay. From here, connect to here. Sorry. I think I should do this like this. Okay. So now that I've connected this in a resistance, I mean a series resistance, resistor and parallel resistors. So the value is now increased because this is already 3 point something, and now this 1K, so it should increase. So now we have 15.59. So the reason why we use series and parallel connection is that at times you will need certain value of resistor, maybe to get certain value of current, since you already have your voltage fixed. So in that case, we need to manipulate, and that resistor is not available in markets or in your workshop. So you need to manipulate the value of the resistor by using series and parallel connection to get the total value of resistance that you need. So in the next tutorial, I'll be introducing you to some other related things to resistor, like LDR. So LDR and the likes, LDR, potentiometer, and Wheatstone bridge. So and some other things that you need to know about resistor. Thank you for watching.